Hello, everybody, and welcome to this first Sunday hangout. I'm Chris Lintott, currently in a rather nondescript hotel room in Chicago, and joining me, as you can see, is Chris North, who is in a beautiful and lovely room in his house in Cardiff, I'm guessing. We'll also have a report from Lucie Green, who can't be with us, but has sent us the latest news from the Sun. But the basic plan, as ever, is to spend the next 30 minutes or so talking about the latest in astronomy news from the last month and answering your questions. And you can ask us questions via the Google Plus app if you're watching us on Google Plus, and indeed this is live and you're not just watching this recording, or via Twitter using the AstroFS for Astronomy First Sunday hashtag. Chris, as ever, we should start with an exoplanet, right?
Yeah, I mean, we've been talking about, it feels like for years, we've been having story after story of the nearly newest or the nearly closest thing to Earth outside the solar system, and we've got another nearly like the Earth planet, but this is far more like the Earth than anything we've seen before. This is what looks to be Earth size, so almost certainly rocky, and is in the habitable zone of its star. Its star is a red dwarf. It's much cooler than the Sun is, and so this planet orbits, I think, just inside the orbit of Venus, or the equivalent of the orbit of Venus. But it's
actually the fifth planet in the system. So it rejoices in the name Kepler 186f. A is the star, and then B, C, D, E are the inner planets. So it's a 5-planet system, and as you say, yeah, it's not quite Earth size. It's 1.1 Earth radii. So as Tom Barkley, who was one of the discoverers, said at the press conference, it's more of Earth's cousin rather than Earth's twin. But yeah, rocky planet in the habitable zone, not a sun-like star, but still pretty exciting. What, 400 light years away, something like that?
Yeah, I mean that's on a galactic doorstep, right? So it's relatively close. Certainly not one of the closest, but no, exciting and a sort of a key step to show we've now found. I think we have found planets smaller than that around other stars.
Yeah, but I don't think we've found a smaller planet in the habitable zone.
No.
So that's the exciting thing. But yeah,
so the
I
next
guess
step is a planet like this size in a habitable zone around a sun-like star, I guess.
Yeah, or I guess an actual Earth. Whoever discovers the actual Earth radius planet, as opposed to the 1.1 Earth radii, will probably also claim, and then that should be it for most Earth-like planets at that point. Of course, we may discover that the Earth is unusual in all sorts of ways. I always talk about the fact that we have this unusual moon, right? Or at least it's unusual in our solar system. The only thing with the next largest thing with the ratio of masses between planet and satellite is Pluto, right? Pluto and Charon are pretty much a double dwarf planet, just as the Earth and Moon is sort of a double planet. We did get some news this month about exomoons, or at least a group of astronomers looking at gravitational lensing, so the bending of light by passing objects. Discovered a signature of a planet. So you see a distant star brighten and then fade in a particular way, which shows that something has got in the way. And then they saw a second dip on that light curve. So there's a dip and then another dip, which they say might be the first detection of an exomoon, a moon going around a planet. Of course, we'll never be able to check because the alignment that you need for this lensing is so precise that it only happens once per object. So we'll never be able to check this result, and it could just be that we don't have the difference between the two, so it could have been a pair of stars. But weak evidence that an exomoon exists.
Oh, well, that's exciting. Weak evidence is better than no evidence, I suppose.
Yeah, exactly. I mean, exomoons are going to be hard to pick up, right?
Yeah, I think from what I've read, the most likely way we'll find them is by something called the transit timing method, where the fact that the moon and a planet are going around a star, if the moon is leading the planet around a star, then the planet will appear to the planet is slightly further back in its orbit than it would ordinarily be by some tiny amount, and the transit would appear slightly later. And then if the moon is the other side of the planet, because the planet moves as the moon goes around it as well, the planet is then slightly ahead of where it would ordinarily be in its orbit, and the planet is slightly ahead of the transits happening slightly earlier.
And if you watch enough transits, then you should be able to see this happening. I think probably the problem is that it occurs to me we don't have any really long-term transit monitoring. Kepler was supposed to look at the same field for up to 10 years, but of course isn't going to do that. It's going to do other things instead. It's going to jump around the ecliptic mostly. And so I think exomoons are a tough problem. I may be wrong. I know lots of people disagree with me. There's a guy called David Kipping at Harvard who's written lots of papers about how they might be able to find exomoons, and gives talks that tells everyone that exciting news is coming soon without ever quite telling us or telling the rest of us what the exciting news is. But I think maybe it'll be a while before we know about the moon. But we have an Earth's cousin. So the search for Earth's, we were debating this in Oxford. I think Earth's siblings are Venus and Mars and so on, right? So we're into the extended family.
Yeah, it's a slightly maybe a slightly older cousin, slightly bigger cousin.
Fair enough. Now look, we had to go, while we're talking about solar system stuff, we had some news from Ganymede, which just in the last couple of days, which was rather nice. So this is a theoretical study of what might lurk under the icy surface of Jupiter's. It's Jupiter's largest moon, isn't it? It's the largest moon in the solar system, in fact, Ganymede.
Yeah.
And we know
5,000 kilometers, I believe.
Thank you. Planet-sized. Just happens to go around Jupiter. And so previously, people have thought that it's an icy surface with a liquid moon with liquid inside and maybe a solid core. But this new study suggests that things might be a bit more complicated, right?
Yes, I managed to grab the image off the website. So if people can see that, then this is the new favoured view of what Ganymede might look like. So it's got the brown in the middle, shows the rocky mantle, which is what you sort of think of as being a moon-type thing. Obviously, being so far out in the solar system, there's lots of ice on top of that, but it seems that this ice is in layers. So there's layers of ice with layers of liquid water in between. And the fact that it says ice 1, ice 3, ice 5, ice 4, is there are lots and lots of different types of ice. Ice is a far more complicated beast than you might at first think. There are lots of different types.
Yeah, it depends on pressure, right? So the ice in your gin and tonic is always ice 1, well, unless you're doing something very strange. But yeah, no, that's precisely the point, right? That it's that these different ices form under different conditions.
Yeah, and it seems that the fact that there's this liquid layer under the surface of a moon is actually not that uncommon. Europa, we know, has one. Enceladus at least partially has one. Titan seems to have one. And I think we've known for some time that Ganymede seems to have one. So large moons, and indeed some small ones, seem to have this layer. But this differentiated layer is what's new. And I'm assuming this is from, I don't know, but I'm guessing this is from data from the flybys, where they've looked at the gravitational pull, or is it maybe from the way the surface is moving?
It's from images, I think. We haven't had a close flyby of Ganymede, as far as I remember, but the new result is actually from laboratory experiments.
Right.
And then from computer modeling. The other thing they've had to take into account is that the moon's probably salty, and we've known that because Galileo flew by, not particularly close. So you are right. Of course, Galileo did fly by and showed that there was this deep thing. So spacecraft found some evidence that the sea was salty, and when you put salt in water, it can alter the density, which is quite nice. So if you want to see that, there's a nice tabletop experiment that NASA suggested. If you take a glass of water and you put really, really quite a lot of salt into it, then what you'll see is you've added salt, so you'd expect the liquid to increase in volume, but actually the opposite happens because the water becomes slightly denser because of the salt and because of the attraction between the salt ions and the water molecules. It's a nice tabletop experiment, and when you take that account into effect, you end up with this layered structure, which the team are excited about.
Well, it's certainly exciting. Of course, we hopefully will get to test this in 2030.
30 odd. Yeah, exactly.
Yeah.
When Juice gets there.
Yes, indeed. And possibly, I suppose, the Juno spacecraft, which gets there next year, I believe, isn't going to go past the moon.
No, I don't think so.
But fingers crossed for Juice in the 2030s.
Good.
I guess if we're staying in the solar system, we should take a report from our roving reporter. So our report from Lucie, who's very kindly sent us a a link. So what I'll do is I will copy this link in, and I will share the screen so people can view it. There we go.
We're
Screen
pushing
share.
Hangout technology to its limit here.
We are indeed. So if I do that with screen share, so you'll see a frozen Lucy. That's fine. Hello, Lucy, who's now replaced me.
Lucy.
Yeah. So Lucy's replaced me, and if I hit play, then hopefully Lucy's going to speak and everyone will hear her, but I'll tweet the link just in case. So if you're not following me, Chris E. North on Twitter, and I'll tweet the link. Here goes.
Hi all. Sorry that I can't make this Hangout. Instead, I thought I'd send you just a very quick bulletin on what's been happening for solar physics. I know that Chris likes to make sure the sun is always mentioned very early on hanging out. So what's been going on in the world? Well, from my point of view, the most interesting event recently has been the Space Weather Workshop that was held in the US. It's an annual event, and a wide range of people go. Now, unfortunately, I couldn't go this year, but a couple of interesting talks were given. They're all available online, so I can look through them. The first was about the solar cycle that we're currently in, cycle 24. The peak of the cycle has been eagerly anticipated, and Doug Bezecker, an old friend of mine, announced that we are there, we are at solar maximum. But interestingly, the Northern Hemisphere peaked a couple of years ago. We're only just seeing the peak of something now. Another talk that was given was about space weather in the worst case scenario. Now, normally the Carrington event, this coronal mass ejection of 1809, is taken as the worst case scenario. So, space weather, the term that we use to refer to coronal lights, but also disruptions to our airline networks, electricity, and so on, all with the origin of solar activity. New work has shown that what's important in making a big space weather event is not one coronal mass ejection, but 2, 3 that come very rapid fire. The first one to clear out a path in the solar system, making it easier for the ones to follow to reach us. And if they're travelling fast enough and they have enough magnetic field, and they punch into the Earth's magnetic field, that's when they're disrupted. So, even though we're having a fairly small solar cycle at the moment, we are at solar max, and we're learning more about what it is that sun can do and how to make an effect on us. That's all from me. Enjoy the rest of the Hangout.
And that was Lucy.
Excellent. Always good to have a bit of the sun, and she's clearly worked out that we can't be relied upon to include enough solar physics without some help. I think she's in Japan, by the way, so it was great of her to send that through. We should probably take some questions, and Tony King would like to know why Mars in particular, and I'm guessing compared to, say, Jupiter or Saturn, it is so hard to visually observe, to see stuff on its surface. It's beautifully placed. I'm really enjoying the evening skies at the minute with Jupiter and Saturn. Jupiter and Mars visible early in the evening, and Saturn, of course, nearly at opposition. And it is true that Mars is sort of the most, especially with a small telescope like the 6-inch I play around with at home, really is frustrating if you want to try and see things. And it's all about angular diameter, right? I think that's the real reason.
Yeah, it looks very small through a small telescope, and even through a large telescope it appears as a small salmon pink disk. And the real trick to seeing stuff on the planet is to stare, just to look at the eye, really get your eye used to it. If you stick your eye up to the eyepiece, look at it and go, all I can see is a small pink dot, all you'll ever see is a small pink dot. If you actually stare, then you might be able to get inklings of the pole caps showing bright or maybe some dark features on the surface. What you're doing is you're just waiting for those particularly clear moments that the atmosphere has every now and again to get a really good view, and your eye kind of picks up on them when they happen. So just take your time at the eyepiece.
Yeah, I mean, one thing we need Paul Abel here for this, really, but I've always found I'm useless at sketching the planets. I certainly don't produce anything beautiful, but that discipline of having a pencil and trying to record what you can see, I find really helps me notice those moments where the atmosphere is particularly clear. And so, also, of course, that means that you have a sanity check on what you've seen, because if you sketch and then you come back inside and look up what you should have been seeing, you get some sense of satisfaction if it's close, and some understanding of the confused nature of the human brain when your sketch has nothing to do with the actual planet, and perhaps some more sympathy for the people in the 19th century who saw canals on Mars. I certainly find Mars very tough, I have to say, but it's beautiful. I like its colour. I mean, even with the naked eye, its colour is particularly striking at the minute. It sounds like a silly thing to say, but it's so obviously a red or orangey red or salmon pink or whatever colour it is, but it's so obviously a different colour from particularly Jupiter in the sky, and that stands out really, really clearly at the minute.
And of course, it's near Spica in the sky, which is a sort of bright white colour, almost colourless, you might say. So the contrast there is quite striking.
Speaking of planetary observing, of course, Saturn is at opposition in the next day or two, and there's the nice effect with a Saturnian opposition when it's opposite the Sun in the sky, so that the Earth, Saturn, and the Sun are in a line. You suddenly get a brightening, particularly of the rings, because all the ice in the ring particles suddenly reflects back to Earth. So you should look for a brightening in Saturn's rings over the next couple of days, and it looks like it might actually be clear tonight. So I know I'm in the middle of Chicago, but there's a lake there I can stare out over, so I might go and have a look at that later on.
I think if I recall, opposition is I've got in my head the 10th of May.
Yeah, that sounds about right.
So yeah, in the next week or so, it's going to.
You see, I'd obscured the fact that I couldn't remember the exact day by saying in the next few days, but you've now made it clear to everyone that we're not as prepared as we should be. Shall we go? Let's take another question. Let's go from the near to the very far. And Eric Ems asks the burning question, which has been a burning question for a while, about the latest news for the Bicep 2 discovery. So this is the discovery of what seemed to be the signature of inflation, the rapid expansion of the universe in the first trillionth or so of a second after the Big Bang, which I've got very good at saying very quickly. Blimey. I don't know if you can hear that. That's a motorbike going down the street outside. Anyway, Bicep 2, and in particular this month there'd been several news reports reporting on a speculative paper that claimed to have reanalyzed the results and found that interstellar dust, so dust in our galaxy, as observed by the WMAP satellite, was correlated with the signatures that were being seen. So, as ever, this is both a difficult question and your problem. This is your territory, Chris. So what do you make of it?
Thanks. Yes, this is it's highly debated, certainly, as to whether there are foreground effects, as they're called, that could be responsible for the signature from the Big Bang, from inflation. It's with the data that's available so far, it's really hard to tell exactly what's going on. The data that we've got from existing surveys is just not quite at the right frequencies. It's not quite of high enough resolution and sensitivity to be able to tell. As has been said before, what we're really waiting for is information from the Planck satellite with its wider range of frequencies, so wider color coverage, if you like, in the microwave part of the spectrum, and slightly higher resolution and much greater sensitivity. That'll really pin down where the dust is, and in particular we're looking, we talked a lot about this last month, so I won't go into all the details, but we're looking at the polarized light, the polarization of the light. And so the polarization maps from the Planck satellite will really help nail this problem. Not necessarily.
I think that's true, but I mean, given what Planck's optimized for, I think we're also looking, aren't we, for other ground-based results to get on with observing this. I think I'd be more confident with the confirmation coming from probably something sitting near or next to Bicep 2 in the Antarctic. I think Planck, of course, has to look at the whole sky, which for most sites is good, but makes it harder to pick out things like this.
You're right. Yeah, Planck's science goals are many and varied, and this would just be sort of one part of it. There are other experiments that you mentioned. So there's the South Pole telescope, which sits next to Bicep 2. That's looking at very, very high resolution. And there's also the Atacama Cosmology Telescope, which is in the Atacama Desert, which is slightly further north.
As you'd expect from the name, really.
Indeed, yes. And there's other experiments. There's one called Polar Bear, also sighted in the Atacama Desert. They're the main ones I can think of at the moment that are going ahead. I don't think I've missed any really significant ones that are due to or could put out results in the next few months or the next year or so. It's over the next year or so. I think we'll really get some feeling as to how reliable this Bicep 2 result is.
Yeah, but feel free. I mean, I'm sure we'll end up discussing it most months on this this hangout. So, Pip Jennings, hi Pip, says he wants to know about the predictions stroke hopes for the G2 gas cloud, and actually, I think it has a has a more solid future ahead of it than I would have bet, because this is the cloud that's in very close orbit around the black hole at the center of our galaxy. It's already been slightly spaghettified, stretched out along the course of its orbit. But it went through its closest approach of its current orbit just a couple of weeks ago, and it seems to still be intact, or rather, in an astronomer's telegram, because we still communicate by telegrams, people, from the UCLA group, Andrea Gez's group, who've been keeping an eye on this, say that it's still intact and that therefore it is robust, which I think is a beautiful description. What this probably means is it's not just a dust cloud. You may remember we've gone back and forth about this, and talked about it being Earth-sized and then Jupiter-sized and so on. But if it's still intact, while going through its closest approach to the center of the galaxy, then it probably has a star within it. So this will be a star embedded in a dust cloud, and we haven't seen the star because it's embedded in this dust, which re-radiates in the infrared. So that's actually quite exciting, I think. And lots of people are going to be watching this over the summer. It's a great time to be looking at the galactic center, and yeah, it'll be fun to look at what happens over the next couple of months as it comes out of what we seem to be calling periaps, the closest approach to the black hole at the center.
I think periaps is closest approach to the object.
That's right, yeah. I think we should call it peri-black hole, but I guess it's a bit of a mouthful.
I can't remember what the there is a Latin version of that. I can't remember. Yeah, I do remember looking it up, I think. But,
okay.
I'm sure Wikipedia explains.
We may have found something we don't know that Dave Rothery doesn't know either, so that he cannot appear and tell us these things, which would be pleasing. But yes, no,
it's
good
going to be exciting to watch this. Yeah, it's going to be incredibly exciting to see what happens to this. It's largely been done with radio telescopes and submillimeter telescopes so far to look at the dust emission from here. So we'll have to see exactly what goes on. Perhaps maybe
these results are from Keck, so it's infrared.
Oh right, okay. So that's so it must be warm dust then. That's fine.
Well, yeah, I guess it's being heated by the star, right?
Yeah.
The images are rather good, but yeah, sorry, I don't have them for you. I guess we should say Universe Today's article on this was rather good, written by Nancy Atkinson, and she points out, of course, that whatever happened actually happened 25,000 years ago.
Yes.
So we're watching this in real time, a long way away. But it's been a good month for dynamic astronomy, actually. There's this escaped star cluster that I know we had some questions about. I think you checked up on this story.
Yeah, I had a quick look at this. So Chris Ralph asks, is this new high velocity cluster likely to be visible in binoculars or a 12-inch Dobsonian? So my first response was to go searching exactly what was going on with this high velocity cluster, and what's happened is that astronomers staring at all objects seen towards the Virgo cluster, which is the nearest large cluster of galaxies to our own, have been looking at the velocity of these objects. And some of the objects you see are stars in our galaxy, and some of the objects are galaxies and globular clusters within the Virgo cluster. And they found one that is moving at a very high velocity away from the Virgo cluster, or more specifically, is coming towards us at a high velocity. Now we don't know how far it's moving sideways, so the fact it's going towards us doesn't mean it's on a collision course.
And also, that's why it took so long to work out that Andromeda was going to collide with the Milky Way, because it's easy in astronomy to measure the line of sight velocity, the things coming towards you or away, but it's actually rather hard to do transverse, to do left and right. So
yes, that's very much the case. So we don't know exactly where this is going to end up. But what I could do, I suppose, just to indicate how much of how fast this is moving, I grabbed the image out of the paper. So if I do this, then you should be able to see
cool.
Yeah. So this is the histogram. So this is the plot of how many objects have different velocities relative to the Sun or relative to the Earth.
Right. And this is from this direction of sight towards the Virgo cluster.
Yes, these are all seen towards the Virgo cluster. So the big purple or pinky magenta blob you can see there is just the clusters in the Virgo galaxy.
What's cool is the width of that will give you an idea of how massive the cluster is.
Yes, so we can tell from that most of the cluster appears to be moving away from us at centered on about 1,000 kilometers a second away from us, but there's bits moving faster towards us and there's bits moving faster away from us as the galaxies all move around within the cluster.
Yep, you can see there's a bunch of stars which have basically no velocity, so that's our galaxy getting in the way, right?
Yeah, so those are our stars in our galaxy that happen to be between us and the Virgo cluster at the moment.
Yep.
And then there's what's labeled as GCs in this plot, which is globular clusters. Now, these are identified as globular clusters from the fact that they don't necessarily look completely point-like. If they're large enough, we can tell that. But then also the fact that the color of them tells us they're not just single stars. They're predominantly made of old stars. They're very red, but also very bright. And if something's very red and very bright, it's probably a globular cluster rather than an old, small, faint, cold star.
Right.
And then
the brightness, mostly, right? I mean,
yeah, the color and the brightness, yeah. And then the other thing you can look at is down in the bottom left corner of this plot, you can see one object which has a velocity of 1,000 kilometers, minus 1,000 kilometers per second. So it's coming towards us at 1,000 kilometers per second. It has the color. This isn't shown in this plot, but it does have the color associated with globular clusters. And so it's a globular cluster moving towards us. The chances are it's been involved in a collision with either a black hole in the halo of M87, which is the largest.
And by a collision, you mean probably a close encounter, right? It's a gravitational collision.
Yes, that's right. So it's an interaction with a black hole, or possibly two black holes. The other possibility is that it's coming from the center of M87 and was involved in a very close interaction with the black hole in the center. And the only way you can really get a globular cluster or any object to be thrown out at a very high velocity is if it didn't interact with one black hole, but with two. So if it came out of the center of M87, that could imply that there are two massive black holes in the center of M87, implying that it's a combination of two galaxies.
Okay, so hang on, let's take this step by step. So the interaction with two is because it's easier to expel stuff in a three-body interaction, right? In a three-body interaction, you always lose the least massive thing.
Yes, that's right.
People model globular clusters as evaporating by this sort of process. So the clusters themselves would evaporate. And so, all right, so I get that logic, but then presumably the black holes are at the center of M87 or close to it. We know there's an active black hole at the center of M87. So that would mean that this cluster must have been close to the center. We don't see globular clusters. I mean, I'm tempted just to say that
we do see some globular clusters so close to the center of galaxies. Really? So there's the Archies cluster in our galaxy.
Yeah,
Omega Centauri is fairly close to the center of our galaxy. So you do see them.
Yeah, and I guess M87 is a mess. It must have assembled. My guess is it assembled through lots and lots of mergers, right? So it doesn't hugely surprise me. One thing I couldn't find was how recently this thing must have been expelled.
Well, that's something that they don't know.
We don't know the transverse velocity for starters, so we can't quite work it out. Yeah.
That's something without knowing exactly how fast it's moving. It does, just looking at its velocity, it does seem to be moving very fast. It does seem to be almost certainly moving straight towards us, as it were. It's probably not moving sideways very fast at all.
And so, did we answer Chris's question? It won't be visible in binoculars because it's still many millions of light years away.
It's about it's in G band. It's magnitude 20, if I recall the numbers. That's pretty faint. So that's probably beyond the reach of most amateur equipment.
Yeah, I'm glad you said most. Every time we say that something's beyond the reach, but the 20's pushing it. Good.
Yeah.
So the other news, talking of galaxies and alignment, there was a really nice story that didn't get any coverage, really. A little bit, I suppose, which is a result about a supernova called PS110AFX that went off, actually just supernova 10AFX, went off in 2010, which was a Type 1A supernova, which is always exciting, because they're the ones we use to measure the expansion of the universe. But this one, and we do that because they're standard candles. They're supposed to go bang with roughly the same brightness. In practice, you have to do some fiddling, but basically they have similar peak luminosity, so you can work out how far away they are by finding out how bright they appear in the sky, which is great, except that this one was about 30 times too bright. So it looked like a Type 1a supernovae, but it was brighter than it had any right to be. And so one explanation for this is that some Type 1a supernovae are actually completely different and have much brighter, are much brighter than they appear to be, which would throw off the entire cosmic distance scale. Not in a useful way. It's the fact that most Type 1a are fainter than they should be that gives us the idea the universe is expanding under this thing called the influence of this thing called dark energy. But nonetheless, that would be worrying, stroke interesting, stroke exciting. But there's a much more prosaic explanation came out this in the last couple of weeks, which is that a gravitational lens has caused the brightening. So there was an intervening galaxy between us and the galaxy which this distant supernova occurred in, and astronomers have gone back and managed to find evidence by looking actually at the oxygen emission of the lensing galaxy that sits in between. So they've observed the thing that caused the brightening, which is very interesting and now relegates the supernova back to being merely, I guess, mildly interesting. Oh, cool. Nice diagram, Chris. Yeah, so
yeah,
I'm not quite sure what the... I suppose that yellow thing's supposed to be the supernova. And as you can see in this highly technical diagram, it's become brighter between the left and the right because of the effect of the gravitational lens.
Yeah, that's the basic idea. And for completeness, we can show the original Discovery image as well. So I showed that earlier as well. So that's the image of the supernova, I believe.
Excellent. As you can see, it's a beautiful thing.
Yes, it's a blob.
Good, excellent. Well, I think we've got to the... We've almost, for once, we've almost finished on time in one of these hangouts. But I hope everyone's enjoyed our roundup of the week's news. Some of us, Lucy, Chris, myself, Paul, Pete, who knows who else, will be here as ever on the first Sunday of next month. And in the meantime, we strongly suggest you go and look at Jupiter and Mars, and particularly Saturn, in the weeks to come.